Alright, so in this video we're going to be looking at the concept of a variable, also looking at assignment statements, and then finally some of the various data types that are supported by C++. And then in the next video we'll look at using some of these concepts and constructing a new program. Okay, so oftentimes when we write a program, we're interested in being able to store some particular data value and then make use of that particular data later on. And the way that we can go about doing that is introducing this concept of a variable. And a variable is just simply a named location in memory. And the reason why we want to have a named location in memory as opposed to an unnamed location is that we want to be able to quickly and easily retrieve some particular value that we've stored at a memory location. If we did not have a name for that location, then we would be relying upon the actual address, and we'd have to keep track of some sequence of numbers, sequence of digits of the address value in order to reference that particular value that we've stored. But we don't have to do that. So again, a variable is just simply a named location in memory. So we may write a program in which we ask a user for their age. And so the way that we can do that in C++ is that we have to specify both the type of variable that we're going to have and also the name associated with the variable. So in our age case, we could have the type being int to stand for integer. So this is one of the data types, built-in data types that C++ supports. And then the name would be age. We'll put a semicolon there. So this is just a simple declaration statement here where we've specified a type and a name for a variable. And so what happens is we get a space or chunk of memory allocated to us, and associated with that chunk is the actual name age, and then the type was going to be int. So we've got type here, and we have the name here. This is just a logical view of what's going on. And we can also assign a value to this particular memory location. It's actually going to have some value in here whenever we first do this declaration, but in reality you want to assign a value straight away after you make a declaration. So it's just good programming practice to assign a value straight away. So we'll say age, and we'll put 18. And so what effectively happens there is we end up with the value of 18 stored at that particular memory location. So anytime that we want to be able to get access and make use of this value of 18, we can do it through its name age. And there's other data types other than just the integer data type. There's other numeric types. So we'll learn about maybe the float and the double, the short, the byte later on. But there's also types that support characters and then sequence of characters. So maybe we're interested in getting someone's first name or their last name. Then we could introduce a variable of type string. So a string supports a sequence of characters. So let's go down here and actually declare another variable. And we'll say that it's of type string. And we'll call the name of this variable just simply first name. So we've declared a new variable, so we get a chunk of memory allocated for us. And associated with that is we have first name. Okay, so this is just simply the name of the variable. Some people will refer to this as the identifier, but identifier is basically a fancy word for name. And the type here is going to be string. And the way we have this now is that we've simply declared the variable, but we haven't initialized it to anything. So there'll be some sort of garbage here whenever we do this declaration. You can actually do a declaration and an initialization all in one line. So instead of doing what we just did, I'm going to mark this out, is actually we could do string, first name, and then do the assignment operation as well. So that way we're assigning a value straight away and we don't have to worry about this garbage. And this is good programming practice. So whenever we declare a variable, to assign it to a value, or assign a value to a variable. So we'll say the first name here is just simply Bob. And you'll notice that whenever I wrote Bob, I put it inside of double quotes. This is required in order to represent that Bob is in fact a string. So any string that you're going to be writing out, what we call a string literal, that we write out in C++, we have to put it inside double quotes. So over here I'll represent Bob as being stored at this memory location that has first name. So that's the basic idea behind variables and assignment statements. A variable is just simply a named location in memory, and we can assign values to that particular named location in memory via the assignment operator. So this is, in fact, an assignment statement in which we are declaring a variable and assigning a value using the assignment operator. Here we've declared a variable, selected a value that we want to store there, and then using an assignment operator, we're storing at that memory location. And that's basically it. So variables and assignment statements in a nutshell. All right, so let's talk about some of the other types that are supported by C++. And so when I say data types, or use this term data types, we're saying that in memory, how much space is going to be allocated, and then what types of data can we actually store there. Can we store numeric values? Can we store a sequence of characters? Can we store a single character? All this comes down to the data type or the type of data. All right, so we've mentioned briefly about the int, and we know that int data types can store integer values. So these are numbers that would not have a fractional part. And the int data type also has a specific range of values that it can support. But I'm not going to get into the actual range just yet. We may look at that on another day. But in terms of the amount of space that's actually allocated, on a lot of systems it will be 4 bytes. Now it depends on the underlying architecture processor and also what compiler in terms of how much space is actually allocated. We also looked at the string data type. So we saw maybe an example here where we have the string Bob, and we were able to store it into some variable out there in memory with this name called name. Maybe first name, I think was our example previously. And then we could have a string representation of a number. So we have 21 here. So you see that 21 has double quotes around it, but we're storing it into a string variable, in this case called movie. So it may be the title of some particular movie. So always with our string values, the string values will be surrounded by double quotes. Just to contrast that, we see here in the next example where we have another int data type being declared. This time we're using the variable name num, and we're taking 21 and storing it into that particular memory location designated by the name num. So this guy and this guy are two very different animals out there in memory in terms of the amount of space that's actually going to be allocated, and also in terms of the actual operations that we can perform. So with this particular variable here called num, we can actually perform numeric calculations. So we could actually multiply num by some other value or divide it by some value. If we try to do the same sort of operations, numeric operations with movie here, it wouldn't work because this is a string representation. So to us, these may look very similar, but in terms of the way this is represented behind the scenes and the type of operations we can do, they're very different animals. I don't have a mention over here for the actual space that's going to be allocated for strings. This varies according to not only the processor and compiler, but also the size of the string. So you can imagine that a very long string would require more memory than a very short string. All right, so another numeric data type is double. So we see an example here where we've declared a variable of type double and assigned the value 165.8 to that particular memory location designated by weight. So here with double values, we can actually support numbers that have a fractional part or a representation of real numbers. And that's not the case with ints. With ints, you cannot support fractional parts, as the name int means. We're talking about the counting numbers, both in the positive and negative direction, and 0 as well. All right, so on a lot of systems, a double will be 8 bytes. But that varies again. Next, we'll look at character representation. So if we're interested in representing just a single character in our program, then we can use a character variable. So we have the type being char, the name here just being letter, and here we actually have a character literal. So character literals are surrounded by single quotes, whereas string literals are surrounded by double quotes. Okay, so we have single quotes there. So we could not go in here and assign any representation that has double quotes to a character variable. So if we were to come here and type out double quote A, double quote, and try to assign it here, the compiler would complain about that because that is not the types of values that characters support. And it usually has a single byte allocated for a character. And then finally we have the Boolean data type, and the Boolean data type is used for storing true-false values. So we may be writing a game program in which we have a variable called game1, and we can set that particular value to true maybe under certain circumstances. So in this case, only two different values could be stored in game1, true or false, and typically you have a byte allocated in memory for the Boolean data type. So again, this is just a brief listing of some of the other data types that C++ uses, and we'll be using some of these in our future programs.